Bismillahirrahmanirrahim. My name is Muhammad Nazim Iqbal, and here the title of our FYP project is Eyeball Movement Based Wheelchair, and presented by Muhammad Nazim Iqbal, and my group partner is Abdul Basit, and supervisor is Engineer Lal Said. First of all, let's talk about the abstract. Uh, Wheelchair is a mobility aided device, and in the purpose system we are using gaze tracking system, and the user looks at appropriate angle in camera, and it will ultimately move the wheelchair in respective direction. Once image has been perceived, it moves on the second part and the final part of the projected wheelchair itself. So here the table of content, as we followed first abstract, motivation, introduction, methodology, results, and conclusion. So motivation, my group partner met with the accident back in 2019, and this is the motivational quotes behind our FYP. Life is all about balance, and since I have only one language, I understand well. So he had he had a story about the motivation, because he is disabled now. So introduction means several wheelchair have come up to the help people, like voice control manually, but this is the unique wheelchair for the specified disabled person. Need of the more compatible wheelchair for disabled. The idea of the wheelchair control by eye is of great use to not only the future of natural input, but more importantly to the handicapped and disabled. So software description, as we followed, OpenCV image library, which is used for the image processing, and OpenCV is library programming function mainly aimed at the real-time computer vision. It mainly focus on image processing, video capture, and analyze, including feature like face detection and object detection. So we are working on the Python language. Python is an interpreter, object-oriented high language programming language. Image processing based on OpenCV library is installed in Raspberry Pi and memory. So for the hardware, we will use Raspberry Pi, and the webcam, and a wheelchair, batteries, DC motor. So methodology we followed for the final year project is software and hardware configuration. For the software configuration, the first step is the eye blink detection. It will detect the eye, and then detect the movement of eye, and then controlling of wheelchair. First step, as shown in slide, the eye blink. When the eye blink detected, then it will detect the movement of eye, and then it will send a signal to the motor to move in respective direction. So hardware configuration is the modification of the wheelchair, or modification include the assembly of motors, and wheel modification, etc. So as I talked earlier, the eye blink detection, when the eye is open, the eye aspect ratio is almost constant, and when the eye is closed, the eye aspect ratio is approximately 0, which will count as a blink. So movement, for the eye movement, the iris of the person, we focus on the iris of the person. Coming second phase, when it move left or right, up and down, it will detect as a movement. So after that, it will send a signal to the motor, and the motor will rotate in specified direction. So here, this is our flowchart, and starting the system, it will show the message align the camera. After aligning the camera, the program started. So after starting, it will analyze the pupil detection. So we set a scenario for each movement. So when the gaze is looking right, it will move the wheelchair in right direction. When the gaze is looking left, it will move the wheelchair in left direction. And for the eye blink scenario, we set a three blinks plus looking straight, it will move the wheelchair in forward direction. And when the two blinks in looking in any direction, it will ultimately stop the wheelchair. Here the results: looking center, looking right, and blinking and looking left. All the scenarios are covered in results. And here is the video of our uh, uh, prototype. So we are showing the wheel movement. We are taking in weight limitation and weight limitation due to our low power of our motors. So at the end, we concluded a wheelchair through the use of eye tracker is possible and has been achieved, and smart wheelchair based on the eye tracking could be improve the quality of life to the disabled person whose eyes still be used as a normal. The system is successfully implemented to move the wheelchair left, right, forward, and stop. It has we have two limitations. Number one is frame delay, and number two is weight bearing limitation. Frame delay is due to our low processing rate of our microcontroller, and the weight bearing is due to the low power of our motors. So it can be catered in future, and here the references. This is our prototype, and thank you very much. Allah Hafiz.